Hi, my name is Edward and welcome to my LaTeX tutorial. So you might be asking, what is LaTeX, or LaTeX as some say? LaTeX is what's called a document typesetting system. Now, in more layman's terms, what this means is we can create documents such as this one, very clean, often with mathematical notation, though of course it doesn't have to, using a markup language which looks something like this. As if you browse through here, you'll see a lot of dollar signs, brackets, funky notation, which might seem foreign to you, but ultimately this code, this markup language is translated into a document. So really the motivation behind this is that building such a document in Microsoft Word, for example, would be difficult, especially when we're dealing with such a lot of mathematical notation. Really, this is very consistent. LaTeX is very consistent. Although it might seem daunting, it's very simple, and I hope to guide you through it. So first things first, let's set up your LaTeX environment. Now, one option you have is to go with an online environment, and the benefit of this is that you do not have to install anything on your computer, and often it's very easy to collaborate with peers or other contributors. So one popular option is Overleaf. In fact, this is what my college class used. My professor recommended. Another one is Share LaTeX, also popular. Now, if you prefer to have a local environment, one option is Text Studio. It's available on both Mac, Windows, and I believe Linux. You can take a look here. Yeah, looks like Linux. Now, if you're going with a local environment, you're going to have to install what's called a LaTeX distribution. Basically, this is what will allow you to compile LaTeX documents. So if you're on Windows, I recommend MikTeX. You can Google it or go to miktex.org. If you're on a Mac, MacTeX, you can also Google it as so. So let's create our first LaTeX document. Okay, on the left here, we'll type our markup, and on the right, we can preview our PDF. So at the start of every document, we need to define what's called the document class. Basically, this is the type of document we're creating. For example, an article, a report. There are different other types. You can look as you need them. But most of the time, you'll be using a document class type of article. So the way we express this as \document class, curly bracket, article, end curly bracket. So most LaTeX commands will begin with a backslash. So this is what you know. You know you're using a LaTeX command when you see a backslash, and then whenever a parameter such as article is required, you'll be using a curly bracket. Okay, so now let's create a space or environment for our document. So we'll type begin, curly bracket, document. So this defines, this is kind of a boundary for a document. Everything we type within here will be included as part of our document. So we can type in anything here. Let's say this is some text. Let's save. So we need to save this. We'll say tutorial 1, and then let's preview it. Now, one thing I do want to show you is that when we save this document, we have a text file, a TEC. This is our markup, and we have a PDF, which we can view here. So now let's introduce mathematical notation in LaTeX. Now really the basic idea is that to use mathematical notation, you need to be in math mode. And the way we represent this is using dollar signs. So to enter math mode, we start with a dollar sign. We can enter some numbers here, some basic math, like this, and then leave math mode with another dollar sign. And then we can type some more text in. More regular text. And we can save and preview. Let's add a space here. So now you might say, what was really the difference of this? Well, one difference is that you can see the text is slightly italicized. Another is that we can, inside math mode, we can take advantage of some less common mathematical symbols. For example, say we wanted to use the AND operation, which I happen to know is backslash cap. And then we have another expression here, 2 plus 3 is equal to 5. All right, so there we see this AND expression, mathematical AND. Now, if we were to do this outside of math mode, we'd get an error because this is a mathematical symbol, but not in math mode. All right, so let's save, get rid of that error. Now, an extension of this is that we can use something called display math mode. Let me just demonstrate that real quick. So this is display math mode. We represent this using $2 signs. 2 equals 4. And with $2 signs again. Now, one thing you'll notice, we get in an entire line for this expression when using display math mode. Okay, let's talk about spacing now, because spacing is something that's a little bit counterintuitive in LaTeX. So to get an intuitive sense for this, let's erase what we had before and start anew. So this is sentence 1. And on the next line in our text, we'll say this is sentence 2. Okay, so when we built this, we see that both of these sentences are on the same line in our PDF, even though in our text they run on 2 different lines. It's kind of odd, right? Let's see if we add another line break in between both of these sentences. Okay, well, now both of these sentences are on different lines. What's going on? Well, the way LaTeX sees this as an empty line between 2 blocks of text represents a new paragraph. And if we wanted to just add a line break without starting a new paragraph, we could add a pair of backslashes. So this is another sentence. And then if we wanted to have another line break, we could say this. This is a third sentence. And then if we wanted to add actually 2 line breaks, we get another pair of backslashes, like so. So this indentation, what's going on here is we have our first paragraph here. This is the initial indentation. This is another line break right here within the first paragraph. And then this line break in this markup represents a new paragraph starting here. That's why we have that additional indentation. Okay, one more idea that I think is worth mentioning is that additional line spaces or line breaks here in our document create no more space. And also this indentation we have here is just for readability, just stylistic, as personal preference. Let's take a look at lists, different types of lists in LaTeX. One way to do this is to just begin an environment called enumerate, very similar to this begin document. That's a common theme. So for every item in our enumeration, in our list, we begin that item. We denote a new item with \item. For example, say this is a grocery list: apples, oranges, lettuce. If we build that, we see we have a numbered list. However, say we didn't want a numbered list, we could use begin itemize, something very similar: apples, oranges, lettuce. And we'll see that we get a bulleted list. We can also build nested lists or lists within other lists. Let's experiment with that. So let's start a numbered list, for example, here. We'll use enumerate. So here sub1, sub2. See how that looks? You can have lists even within these lists. Let's say this one we don't want numbered. It's not autocorrecting. So I say sub1, sub2. All right, so we can see it might be a good idea. I'll just do it. So indent to make this a more readable. We might also want to use lists in math to show a series of mathematical steps, for instance, in a proof. One way we can do this is by using the align environment. Again, notice this pattern, \begin, \end. What's really cool about this align environment is that everything we type within it is by default in math mode. For instance, if we type in a formula, so I'm just thinking off the top of my head, 2x plus 5 is equal to 10. And then let's say on the next line, we want to have the next step in the equation, subtract 5 from both sides. Let's continue this all the way through. X is equal to 5 over 2. Let's run this. Oh no, we get an error. Why is this? Environment align undefined. This is because the line environment is not built into LaTeX. Instead, you can think of it as an add-on. Some other developer has built a series of commands, one of which is a line and a package. And we have access to this package. So at the top of our document, say \use package. In the particular the package we want to use is called MS-math. So now we have access to this list, or this library of commands, one of which is a line. So now if we build and run, we'll notice the steps are numbered, they're in math mode, neatly organized. Now let's say we didn't want these numbers here on the side. We could just add an asterisk at the beginning, at the end of a line, and run again, and they're gone. One thing you might notice here is that this fraction, it's a little bit ugly, right? So since we're in math mode, we can take advantage of the frac command. This takes 2 arguments, a numerator and a denominator. So 5 would be our denominator, 5 would be our numerator, 2 would be the denominator. Let's run that. Our document would be a lot easier to read if it was divided into sections. That's really easy to do in LaTeX. Just / section, as you might expect. You can either just have it as so without a title, or in the brackets you could include a title. Let's include a title. Let's say list. Let's render that. There we go. And also if we wanted a subsection for different types of lists, for example, numbered lists, bulleted lists, mathematical lists, it's really easy to do also. Let's add one here. A subsection, as you might expect. Numbered lists. We could add another section here for bulleted lists, and then so on and so forth. Our document's looking solid now, but we're still missing a title page. Let's think about some of the things we might want to include on our title page. How about a title, a subtitle maybe, an author, and a date? When we define this metadata, it's actually not part of our document. So we want to include it as part of the convention outside of our document environment. So let's do that. Again, following this \LaTeX pattern. So \title, we define the title, the fundamentals of LaTeX. Our author would be me, Edward, and you too, from Programming Made Easy. A date, and the date is today's date. We could define a solid date, such as what's today's date, or we can do it dynamically, which I think is really cool. So every time this PDF is rendered, it'll update to today's date, or the current date. All right, so let's run here. And we'll notice that nothing happened because we've just defined this metadata. We haven't actually told LaTeX to actually make a title page. So the way we do that is in our document. Go back to our document. We call the command make title, \make title. Run it. There we go. We got a good title. However, I think it might look a little more professional if it was on a different page, a separate page. Create a new environment. And we do begin. So \begin, title page. And then we can copy our make title into our environment. So there we go. We got the title page on a separate page. Making a table of contents is really easy, so I might as well just show you. So let's see, after our title page, we'll just call the command table of contents and run. There we go. Although I don't really like how it's merged with the rest of the content. So after table of contents, I'll just call the command new page, and that just basically inserts a new page. That's definitely useful to know in general. That's definitely an advantage over Microsoft Word too. Just notice how it dynamically numbers everything. So if we change different sections, rearrange them, we wouldn't have to worry about that. we just call this command, and LaTeX takes care of it. That's really the beauty of LaTeX. Before we go, I thought I'd show you this really neat tool that I found called Detectify. So since there's so many symbols in LaTeX and really in math, it's impossible to memorize them. So this is really just handy to have. So basically you draw using your mouse on this notepad and it'll try to recognize, match it with the appropriate symbol, and it'll give you the corresponding LaTeX command. It's really cool, works well. Alright guys, so I really appreciate your viewership, and if you benefit from this tutorial, please like it. I really just made this for fun. I have finished an algorithms class, and I thought this would be a good review for myself and also help out some other people, because LaTeX was definitely something that it wasn't necessarily part of the material, but other people struggled with it because it wasn't formally taught. So I hope this benefits you if you're a college student or anything else. If this video gets 100 likes, I will make a sequel. And if you have any suggestions for future videos, please comment and subscribe. Thank you. Bye.